Hi, everyone, and welcome to the Viterbi School of Engineering Faculty Roundtable session with the Computer Science Department here at the USC Viterbi School of Engineering. We are running a little bit behind because we were just trying to do some back-end stuff, but we're glad that you're all here. We got a number of you here. Thanks for being here. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the USC Viterbi School of Engineering. We have a few of our faculty members here. We might have one more join. We're still trying to get in touch with them on the back end. So we had some technical difficulties, but we'll allow first to have them introduce themselves. And then I'm going to tell you how this event's going to go. So Dr. Halfond, do you want to start with you?
Sure. Hello. My name is William Halfond. I'm an associate professor here in computer science. My area of specialty is software engineering. I'm also the associate department chair for undergraduate affairs.
Thank you. And Dr. Raghavachary.
Hi, I'm Saty Raghavachary. I'm also an associate professor of teaching practice, and I teach courses related to programming, databases, computer graphics, and data science.
Thank you very much. Now, for all of our guests that are joining us today, here is how this session is going to work. I'm first going to lead a discussion with our faculty on computer science as a discipline. We'll talk about the programs, we'll talk about the academic areas, we'll talk about the classes and the majors, et cetera, and just what to experience from an undergraduate perspective. We'll also talk a little bit about research in the area. And I'm going to hold those questions kind of among our faculty, kind of get some good kind of background on the area. And then toward the latter half of the session, I'm going to open up the opportunity for you to jump in and ask your questions. But for the time being, please hold your questions. So no questions right now, and you don't want to ask questions yet. I will make sure that we do that as we get in. I also want to make sure that Michael Cox, can we actually dismantle the chat function for our guests as well? Because we want to make sure that we will have only the questions through the Q&A feature. So let's make sure we do that. We had some technical difficulties, but it looks like we got it fixed out. Dr. Nealan, do you want to introduce yourself?
Yes, sure. Sorry for being late. I think I hit the wrong link, but anyway, good to be here. Hi, everyone. I'm Andy Nealan. I'm an associate professor of cinematic arts and computer science. I sit between the Viterbi School of Engineering and the School of Cinematic Arts. I teach game prototyping, computer graphics, and artificial intelligence. Those are all CSCI classes.
Awesome. Fantastic. And by the background of your office, it looks like this is nothing but an entertaining area that you got going on here. This is where you do all the magic, right?
Not bad. I'm not gonna lie, it's not bad. It's my music and games things.
I love it. I love it. I love the background. It's awesome. So as I said, I'm going to be leading the discussion in the beginning, and then we're going to make sure that we have your Q&A in a little bit. And I'll tell you when it's time to ask those questions. We're going to go for the hour up until 5 o'clock. So my first question to our faculty, and maybe GJ, this is one you want to take the lead on, but then anyone else wants to jump in. Seemingly a simple question, but we got a lot of guests in attendance that are in high school with various understandings of what computer science is, what it might be to them. Maybe they've taken computer programming classes before, maybe they've never done it before. What the heck is computer science? What's computer engineering? What's the deal? How do we explain it? How do we understand what the degree program's about? I know a loaded question, GJ, but I wanted to softball it up for you to get a lot of detail to these students.
Sure. You say it's such a simple question, but I think that, we've got 3 faculty here, and we've probably got 5 opinions on what it actually means.
And that'd be great. Yeah.
From the simples, there's the first part we think of computer science is programming, and that's a big part of learning computer science is also programming. It's a lot like if you want to study Spanish Lit, you have to understand Spanish language itself. But it's a lot more than just that too. There is a lot of theory and algorithms that go into it. Some of the classic algorithms that we use in computer science to efficiently solve problems, especially problems related to large amounts of data. Then there's specialty topics that you look in that take both the programming skills and also the theory skills and start to apply them in certain areas like databases, graphics, artificial intelligence. And then lastly, I think wrapped up in this too is how you take these things and apply them to real problems. How you take your ability to program and how you take your ability to think through problems in an algorithmic way and try to solve real problems that don't just exist in the text on your computer screen or in your textbook. They actually exist out in the real world.
Any other thoughts, Saty or Andy, you want to jump in and what computer science is?
Yeah, I'll say something similar to what Professor G just said, which is, so today we have C++, Java, Windows operating systems, Linux, Mac. So imagine in 20 years from now, all that just go away. So what is left would be hopefully some background about from where all that came from, and then what do you do with all of that? So I would answer that computer science is those things that are left behind that are beyond just simply the programming and the operating system. In other words, it is all the theory, all the processes, the algorithms, the steps that underlie what you would actually do with things like C++, which is write a video game or create a server or do 3D printing. But it's more the principles and the theory. It's a science after all, just like any other science. We have our own theory, principles, background, foundation. That's CS.
The only thing, okay, so my take on this is usually, so the common wisdom usually is that whatever is currently the hottest topic in computer science is what people consider to be computer science. And right now that's AI.
Right.
But 10 years ago, it was graphics. And
Right.
20 years ago, it was experts, or 30 years ago, it was experts. So it changes all the time. And exactly what the previous two said, like the underlying theory and principles, those have actually shifted a little bit, but not as much as the surface hot topics, right? So I think the important thing to understand when you're taking a computer science degree is that you will understand all the applications, but it's very important that you come out of college with like a really firm understanding of the basics, because that will allow you to do pretty much anything in the field, and the field is tremendously large.
Great, thank you. It's like you're reading my mind. You're fast forwarding to another question I'm going to have in the future. And again, please hold your questions for the time being. So Sean, we're going to take 10 points off your application before you even apply, for even asking, for not following instructions. Okay, so don't test me, Sean. Don't test me. I know, but please hold your questions. We'll get to it in just a little bit. Okay. This is my next question on computer science, and this is a great background. Can we explain what the undergraduate degree programs are that relate to computer science at USC? What's available? What are the differences between them? I don't know who would be great. DJ, do you want to start it off? And
Sure.
they'll just nominate you.
Okay, I'll pass it off to Andy though when we get to the games. But
yeah.
So broadly, we have 4 degrees that are offered in the computer science department. The classic computer science degree. We have a joint degree with the Department of Electrical and Computer Engineering. We call this computer engineering, computer science. We have another degree that is a joint program with the Marshall Business School. We call that the CSBA, Computer Science Business Administration. And then we have a 4th degree, which is a collaboration with the Cinema School. We call it the CSGM degree. That's a CS Games degree. So at the core, all 4 of these degrees start you off with a lot of the similar kind of stuff. So you're learning your basic programming skills, moving up to advanced programming. And then you're also learning theory, moving from simple kinds of discrete math to more advanced computing automata and computational complexity. So you're learning these kind of core foundations that is shared by all computer scientists, regardless of which ones. Then you start getting into a little bit more specialty areas, and CCS has a little bit more requirements for electives that are going to teach you about the underlying hardware, the computer architecture. CSBA is going to incorporate classes on marketing and accounting. And CS Games is also lots of fun, and it's going to incorporate things on graphics and just specific game design and gameplay ideas.
Great. Any other thoughts on those? That's a great description. Maybe we can jump into some courses. Maybe you all can touch on courses that you teach, but what can someone come to expect from the undergraduate degree, the undergraduate degrees in computer science? What types of courses happen? And maybe I'm going to actually preface this with a question. What's the difference between taking something like AP computer science in high school versus getting a degree in computer science down the road? If maybe that's where a lot of our heads are at in this webinar. Whoever would like to go.
I mean, I can try to tackle it.
Yeah.
I mean, so as a person who did not go to college in the U.S. Or in high school, like none of the, I did all this in Germany. There were no AP classes when I was in high school. So I think the biggest, so you're going to go a lot deeper. So as far as I am understanding it, when you're taking AP classes, it's predominantly a programming class, right? You're going to be pick Python or Java or a language, and you'll learn the language or you'll learn the basics of it. But you won't necessarily, again, do all the foundational treatments of complexity theory. How long does something take to compute? All these like more in-depth analyses so that you can actually then go out, because what you've been doing up to now probably is looking up algorithms, right? Or looking up solutions to problems. Ideally, in the future, you will be understanding this stuff so well that you can actually go out and solve new problems, right? Because of the fact that you have understood the foundations of computation and the technology, irrespective of what that looks like in 10, 20, 30 years down the line, because again, the basic algorithms potentially will not shift as much as you may think. I think that's one big difference, but that's the first 2 years, right? The first 2 years, you're learning mostly a theory, and then depending on which of these 4 different degree programs you choose, you'll be going into much more specialized skills where you will be able to apply all that knowledge to solve the more specific problems that you face in those fields. And of course, it's 4 years and not one class. It's a lot of classes.
Right.
A lot of classes.
Right.
Now, to give a practical example with the game engines, for example, so you can go on the web and download Unity or Unreal, and then go through a few tutorials and build a game, and then actually make a web player, have your friends play it. But then you don't necessarily know exactly how the game works. For example, they might have what is called physics, and then all the balls bounce around and magically looks like the real world. So you can actually use something without knowing how underlying it's implemented or how it works. Whereas in a graphics course, if you actually take one of our graphics courses, we'll teach you, there's a course called Game Engine Architecture that actually tells you not how to use Unity, but how to create Unity. So that is also a fundamental difference. So you learn the principles of how these things are built in the first place, or how is Maya built, for example, or how does computer animation algorithms work. So in a way, it is all about behind the scenes of what people do with all of this. Whereas from the outside, I think like AP Computer Science in a Java class teaches you just Java programming about how to balance a tree, for example. But you might not know what a tree is or why you would balance it in the first place, or what actually goes in a tree. So in our courses, we actually teach all of that.
Going on this course conversation, Dr. Halfond, do you want to jump in and tell us about some courses that you've taught in the past, or maybe courses you're teaching now and what that covers? Sure.
Just from an undergraduate's perspective, I've taught 2 courses. One's a freshman academy, but it's not really a CS specific. Sure. The one that I've taught is Computer Science 310. That's software engineering. And I think this is best described as the process of building large-scale software systems. And, some people, when you learn to program, you learn how to build some simple programs. Maybe there are a couple hundred lines of code, maybe a couple thousand lines of code. These are small, easy programs. Expect most people after a year or 2 of college programming can do. But software engineering is really teaching you actually about how to collaborate in groups that are working to build very large-scale systems. And so we learn about things like how to do automatic versioning control, how to do automated testing, both at the unit level and also at the acceptance testing level, since both of those are really important in industry. And then we're also learning different things like design methodologies, how you deconstruct going from software requirements all the way down to your software architecture and your low-level design, all the way down to when you're finally ready to create the code. So we learn all about that aspects of the process. And so we learn some hard skills, but also this is the first time you have to truly work in a group, in the sense that you can't just, one person can't do it all. You really have to work together in a group to make these systems work. So students also learn a lot of good lessons about teamwork.
Fantastic. Yeah, collaboration is definitely key, and a key distinction of our curriculum across the engineering computer science curriculum. One question I have for all of you is when we talk a lot about this idea of theoretical work and hands-on work, can we dive into that a little bit more about talking about examples of what would be coursework in theory, or what it mean would be to take some theoretical work versus the hands-on approach, and also that balance that you'll find in the education? Saty, you want to take a stab at the beginning here?
Yeah, sure. So one of the classes that I teach is a graphics programming class. So the final project for that is made up of teams that have 3 or 4 people. So then the difference would be that on your own, when you do the first few homeworks, there are small programming problems that test you on one algorithm and how to implement that. Whereas the group project is something bigger, where you pretty much take everything that you learned in class and then put it together in one final 3-minute animation, for example. So then the group splits into different pieces, and then each person goes off and implements their aspect of what it takes to make an animation. And finally, everybody brings it together. So it is something like, previously mentioned, one person couldn't have done it all themselves. And so you need like 3 or 4 people to work on it. And it gives you a chance to show off back to the instructors what you actually learned. So then it's pretty gratifying from our point of view that there are 10 different teams in class, and each one comes up with a pretty cool project, and they basically blow our minds. And like, wow, you learned all this from us, and you show it back to us. So that's really what the final project is about. It is about learning to apply what you actually learn. Then when you join DreamWorks or some game engine company, Blizzard Entertainment, it's more of the same. So you already know what to do, but then they scale it up. So you have a little miniature practice version of what goes on in the real world. That's the project aspect of it.
Any other thoughts on theory versus hands-on?
So I teach, as I said, I teach AI, which is not a theory class, sort of, but it has a lot of theory in it. So it builds on the idea that you come when you start in your first couple of years, right? You're taking the basic programming classes, you're taking discrete math, you're taking object-oriented programming, and all these different like foundational things, and theory of computation. So then when you come into AI, I can start off on like graph theory and things that are a little bit more advanced and a little bit more complex that all build on that, and then sort of reach into the practical applications of it, but are still very firmly grounded in the foundations that you need to understand in order to make your algorithms efficient. On the other hand, I teach game prototyping, right? And game prototyping is a class that is 100% practical. It just assumes, for example, that you have some background in using the computer. Like it's actually not that, it doesn't require a whole lot of theory, but it does require that you have a very strong familiarity with some tool set. And then you're making like one game a week. Like every week we go through a different prompt, we come up with a different topic, I lecture on that topic, and then the next week you present a prototype that you made in a team of 2, and every week you're working with a different person. And every week you'll present that game that you worked under. Like, for example, this week the prototype prompt is discretization. So how can you make something that is space-time discrete, that moves forward in chunks, versus something that is more like a first-person game, right? And then all the students have to make that, but they only have 1 week, which makes it so that you have to make something very, very tiny, but that exemplifies the prompt and maybe tries to do something entirely new that we haven't seen before. And that goes through the entire semester. So you're making new stuff all the time, right? Wow. So we have both like very, very fundamental theory, and then extremely hands-on applied applications with real world applications with people in teams.
Absolutely. And I think that's something to highlight about our programs in general, is that we don't emphasize one necessarily over the other. It's the combination of theoretical work and hands-on work that really prepares you for your next steps, whatever that's going to be, whether that's going to graduate school or going into industry, or likely some sort of combination of the two later on. So it's important to have that. Dr. Halfond?
Yeah, I was going to say, building right on that, the one thing that I'd like to highlight is actually the way we've structured the undergraduate core classes in the first 2 years is kind of this lockstep of very practical programming with theory classes. So we have a sequence that is really about teaching programming skills. That's 102, and then 103, and then 104, and then 201. And you're moving from very simple writing functions and code that can compile all the way up to 201, where you're building very complex systems with user interfaces over the network, and they're backed by databases. And then moving along in lockstep with that, you see classes like 170 and 270, which are dealing with computer science theory. And so, what's the mathematical languages that we use, moving up to the very complex ideas of automata and computational logic.
Great, thank you. Can we talk a little bit about shifting gears from the curriculum over to the research element of it? Can we talk about research that's going on in or related to the computer science department? Maybe that's research any of you might be involved in, or that your colleagues are involved in, things that are happening at the school that maybe might be exciting to some of our students that are out there. And that's open to any of you. So I don't want to put anyone on the spot here. Maybe Dr. Nealan, do you want to take this from a games perspective?
Sure. I mean, so from a games perspective, the research, I'll be honest, like it's a much more, so the things that I do in the games area are much more applied. Yeah. That doesn't mean there doesn't exist research in games. The research in games, though, I will say is, to be perfectly honest, like as far as I can tell, if you're not talking core technology, then the research aspect of games is firmly in the humanities, right? So you're looking at more like game studies, how do games impact society, so like all these like different kinds of aspects of that kind of analysis, like sociological analysis.
Game theory.
That said, all the underlying technology, all the underlying technology comes basically from computer science, because the main underlying technologies, right, are networking, graphics, and artificial intelligence, and input devices and controllers and hardware that goes around what alternate devices look like for games. All of those things have their own research fields. There do exist various things that I've been part of that are conferences that try to pull all these things together under one umbrella. But for the most part, and I'll be perfectly honest here, these are disparate, these are disjoint fields. Graphics has a giant conference. AI has, at this point, I don't even know anymore how many conferences that are orders of magnitude larger than the graphics conferences, right? All of these communities exist. One of the things I usually tell students, now again, most of you, we're talking to undergraduate here, right? When you start getting into the graduate level, usually when students come in and say, I would like to do a PhD with you on a topic, could be AI, could be graphics, could be something more games related. I usually tell them that the first thing you need to do in this is find your community, right? You need to find the group of people who you enjoy being around and who you want to collaborate with. And then that usually becomes the area that you do your research in. So it's a combination of your personal interests and what are people actually interested in right now? What are hot research topics? What are like the big questions, right? For example, in AI, one of the big questions right now that is also heavily funded and that a lot of people are looking into is explainability, right? We all have these beautiful quote unquote black box systems now that can do amazing things better than humans. But for the most part, we don't understand exactly why they are as good as they are. We do on a basic level, but not on a per case implementation level, right? Which is having huge implications, for example, for self-driving cars and all kinds of other technologies that probably down the line we will take for granted. But getting to that point is going to require a lot more effort in all of the constituting areas that touch it in some way. So I think anyone who's interested in that kind of research, there are numerous people around Viterbi and SCA, School of Cinematic Arts, that are interested in hearing you out and would gladly advise you on what we call directed research. So you can take, as part of your electives, you can take like 1 semester research projects with the professors who you then identify as the person who'd be interested in your research topic. And that counts as a class. But you do have a deliverable and you have to do a full semester worth of work, finding previous literature, understanding the implications, finding what the state of the art is, what is the thing that you want to do is new, how risky is that? Because it's research, you never really know whether it's going to 100% function. And then you go off and do it. And the result will be that you either solve the problem or not, or you would, at the very least, you will have had some valuable insight, and then you collate all that information into a report. So that's, from my perspective, that's what undergraduate research looks like. Usually it comes in the form of directed research projects. Rarely, but not never, have I seen undergraduate students publish at very, very well-respected conferences like SIGGRAPH. Like, it does happen. But for the most part, because usually the undergraduates are busy with coursework, it's much harder to pull off.
Other areas in research?
Yeah, go ahead, GJ.
Oh, I was just gonna, sorry, I was going to give kind of a non-answer, to be honest, because
Yeah, go for it.
like 90 faculty here who are doing research. We've got 2 huge research institutes, ISI and ICT, who do either security work or virtual reality work, plus I don't know, dozens and dozens of faculty who are all research active and working on projects. I think any major area of computer science research, we have 1, probably 2 faculty who overlap with that. So it's I think the question is more like, can we find an area that we don't cover?
Right.
Probably a shorter conversation than to highlight all the active areas of research. But that includes databases, AI, robotics, software engineering, graphics, games, computer theory. I've now that I've tried to enumerate the list, somebody's going to get angry at me for having forgotten their area.
But it's true though, USC has a pretty nice large roster of faculty, so they do it all. I don't include myself, I said they, because I'm part of teaching faculty. So I do directed research with one student at a time. So one student is actually doing music visualization. He loves music so much. So he's trying to combine music and graphics and make a pretty cool product out of it. A different student is doing data visualization. He likes data science and again, graphics. So you have opportunities to, work with professors one-on-one at the undergraduate level. But overall, as a department, USC basically does it all, like Gija mentioned. Plus the two extra institutes, ISI and ICT, those are like adjunct computer science departments that USC has had for a couple of decades, actually. So if you combine those as well, then we really do every kind of CS research in the world.
Thank you for that. A question that we get a lot, and Dr. Nealan, this is something that you mentioned before, whatever the hottest buzzword is in the area is always what everyone's interested in. And I often get high school students come up to me saying, I don't want to study computer science, I want to study artificial intelligence. How do I do that? Or I don't want to study computer science, I want to study data science. I don't want to study computer science, I want to study machine learning. I don't want to study computer science, I want to study everything you just listed, GJ, about research. And so can we talk about how there's that idea of these things are cool. You read about it in Wired magazine, you hear all the articles, you hear about that AI conference that was made by AIs for other AIs. What do you want to, how do we talk about this undergraduate degree program and how it will include these elements, definitely, and where this goes as far as the advanced education beyond that?
Andy teaches all the cool stuff, so we should probably let him go and
yeah.
tell us how he responds to this.
I mean, so basically everything you just mentioned, Paul, is what you're studying, right? It's because you will, so the course, the programs, those degree programs that GJ mentioned earlier, they give you enough flexibility that especially in you can start sooner, but for the most part, it's going to be in your junior and your senior year. Like in those last 2 years, those are the years where you get to like pick the electives, right? So if you want to do machine learning, go by all means, make it a machine learning degree. If you want it to be more of a classic AI degree, that's fine too. If you want to focus on games, if you want to focus on databases, software engineering, programming languages, literally anything you can think of, right? Of course, then the joke usually goes, oh, wait, in 20 years from now, there will be no computer science department anymore. It will just be called the artificial intelligence department. So that's what people say now, but there are some indicators that things are collapsing into other fields. If you look at the current research fields and the sizes of the conferences, but all of that is in constant flux, right? This is why I think computer science departments have like strayed at the idea or like balk at the idea of like being renamed to something, right? It's like there are data science departments, there are machine learning departments, but for the most part, computer science departments who have been around as long and are as big as the USC's computer science department and as well respected and quite frankly, highly ranked in the world. Those are called computer science departments so that you as an incoming student can project anything onto it, right? Because you will get, again, in that first course load, that trajectory that most people take, the core, that will build the foundation to any other degree, be it computer graphics, game engineering, making game engines, AI, machine learning, all those things, right? So those all exist in this degree program. And it's up to you to figure out, not to figure out, right? That's where the admissions and the advisors come in, right? So the advisors help you, and you go to the advisors, you will have an advisor, a personal advisor who's responsible for you. And this person will help you figure out the roadmap after the things that are the required courses in the early stages of the degree.
And back to your point earlier about, I forget who made the point, but this idea of like having the foundation degree of computer science, the coursework and the theoretical work on that allows your opportunities you leverage those skill sets to build into those areas as you go, or whatever's going to be next that doesn't exist right now. My favorite fun fact typically about most computer science faculty is that they've usually never taken the programming language that they're teaching, like they've never taken a course in it because it wasn't being taught maybe when they were going through the school. That I've heard that a few different times from different faculty members. Like, oh, I learned in Fortran. Now we're doing something entirely different. Did I go too far back? Did I go too far back?
I learned Fortran. I am that old. I definitely. Well, so I should. This is a boring side note, but I studied civil engineering once, and in civil engineering and other forms of mechanical engineering, Fortran was the language, right? Like in the late 80s, early 90s. That was the language that you learned. I never, before I taught it, had ever learned Python, right? Because when I was in college, Python was not the hot stuff. Java was the hot stuff, right? And C++ was never the cool kid on the block, but it's the workhorse of almost everything that I do, be it in AI or graph, especially in graphics.
Mhm.
Right? It's just straight up the workhorse. So you'll learn whatever it is you want to learn. Honestly, you get all of the things out of it that you want to get out of it, is what I usually tell the students. And you can do so much on the side, like all the languages that you're not specifically learning in class. Once you've learned a few programming languages, say like 2, almost all the others just, I always assume that learning actual languages is so much harder than programming, right? Because usually it's said if you know 2 or 3 languages, learning a 4th is easy. Usually after 1 or 2 programming languages, I believe learning a 3rd or a 4th, because of the algorithmic similarities, you'll have different, very, very different ideologies and paradigm shifts about memory management and all those different things. But for the most part, some of the core structures look very similar, right? The syntax maybe looks a little bit different, but the core structures are similar.
I want to ask our panelists one more question, but while I'm doing that, for all of you that are watching, I want to give you the opportunity now to start getting your questions ready. And here is how the questions are going to go. The questions are going to be put into the Q&A feature. And so you can feel free to start typing in your questions into the Q&A feature. And for all of you, we have hundreds of people out here watching. This is a large event. What you can do is upvote. And so there's no way we're going to get to all of your questions. And so what we're going to have you all do is vote who, in what order we should answer these questions. So you can go on through and hit that thumbs up, whichever one you want to be answered first. And that's the order in which we will go down until we run out of time at 5 o'clock. So we're going to handle this democratically and go through this entire process as we go down. But my last question to our panelists before we get to these questions is, sharing as much as you want to share about your undergraduate experience and where you studied and how you studied. Can you draw some comparisons and differences between what your time in college was like versus what the undergraduates in computer science at USC are going through, what their experience is like, what they're like in general, just trying to open up as broad as possible to basically some vision into their future with some perspective of your past? Is that a deep question?
Yeah, pretty big. I did an undergraduate in civil engineering and architecture. And then when I got bored of that, I did an undergraduate in computer science. So my version of an undergraduate that started when I was 28 is potentially very different from a lot of other people who start younger. This is not to say that you should definitely do a million different undergraduate degrees. I did it in Europe. It's free. It's different. You're not straddled with a bunch of student debt afterward. But the experience of it, honestly, from having one where it felt I didn't really know what I was doing to the other one where I very specifically targeted it, could not have been more different. So the more you prepare for it, the more you prepare for an undergraduate degree in the sense that you have like a deep, keen interest in the subject, and the more you read up on that, the more you will know what it is that you want to get out of it, and the more fun you're going to have doing it, right? And then basically taking all these different classes with the titles that interest you the most, that you want to do anyway, they give you 2 opportunities. A, if you're really lucky, you're going to have a great experience anyway because the professor is exciting and you get along with them and there's a personal connection and all that stuff. But you also are given the time to study these things, right? So it's both a getting from us, right? So we lecture and we give you assignments and we meet with you and we have office hours and all the different ways that you can interact with the faculty, ask questions via email, et cetera, et cetera. But then also comes the part where you bring a lot to the table, right? So you're going to get a lot more out of an undergraduate degree if you look beyond the parts that you heard in the lecture, right? This is a thing that I did not understand the first time around. And the second time around, I, kept on spending probably unhealthy amounts of time being like deeply immersed in the field and in the subject matter. But what that did for me is gave me a condensed 4-year program where I came out and I felt like I'd spent 8 years learning the subject. And now I felt like I was ready to do anything, right? So that's my biggest piece of advice, that you don't stop when the lecture ends. but that you use some of your time that you might have outside of classes to look beyond the things that the lecture just covered and study that on your own, because very likely, depending on what the nature of your future profession is, if it's not academic, like in our case, then it is very hard to find the time to go back to the basics, because the basics are hard to maintain in your memory, right? And you need a lot of time to understand them and to internalize them. And so the more time you use practicing that during your degree program, the better off you're going to be down the line. And it will be a much more interesting experience for you. And that doesn't mean you shouldn't also have a good time because you're an undergraduate, but that part comes by itself, is my experience, especially given the density of campus life at USC.
Thank you. Any other thoughts?
Yeah, so one thing that is guaranteed is no matter what you study in computer science, the next 4 years, that'll almost all be replaced by something more that is going to come along in the next 10, 15 years. But the fundamentals, the principles that you study though, would actually never change. So there's two different things that I'm saying to you. On the one hand, there's the foundation, and the other hand, there's the actual applications. So those applications come and go. That's the tip of the iceberg, but the foundation never changes. So always try and focus on what those foundations are and hold on to them. That way you can keep transferring them to whatever new comes along in the future.
I think one of the really fun things I've noticed here at USC is how involved the students are. Like computer science students, they're not just doing computer science in the classroom, they're involved with like ones of like a dozen different clubs that seem to take computer science in a bunch of different directions. I've really been impressed by that, and really happy to see that there's so many kind of extracurricular options available that include computer science.
Thank you so much. One thing I realized I neglected to mention in our questions is that this is a session specifically focused on computer science as a discipline and for the department. And we want to make sure that we're focused our questions on those questions that our faculty can provide insight for. So any questions related to admission, we're kind of taking out of the chat. We're trying to answer them for you, but also going to, out of the Q&A, and answer them for you as best we can. But I will encourage every one of you that this is one session on computer science, but we have sessions twice a week on admission, specifically about that, where we talk about the admission process, the application process, competitive nature of it, et cetera. I just put a link into the chat for that. So viterbiadmission.usc.edu/visit. You can schedule one of those for first year students Tuesdays and Thursdays at 4 p.m. and we can go into depth on all that. So please, we're going to take those offline there. We're also handling the class size question on that because we can give you a little more detail on that. But let's go to this question that was getting upvoted pretty early from Alexander. Question for Professor Halfond, but I'll let anyone jump in here. A common criticism I hear of CS programs in general is that the tools they use are often outdated and not used in industry. Are the tools and libraries used in the software engineering course for version control or testing the same that are used in tech companies today?
Yeah, that sounds like it's right up my alley. First, I just want to take a general answer and then I'll go specific. In general, what you're learning is less, the focus of the education is less on vocational, where you learn here's how you use this specific piece of software, and more on here's the concepts that this piece of software represents. So in that case, the concepts end up being more important because you could easily transfer them to different specific tools and software. If we're looking at something like CS310, we're using GitHub, we're using Gitflow, we're using JUnit, we're using Cucumber for acceptance tests. We're using Mockito for integration with complex design objects. These are all industry standard tools. In fact, we're using the exact same tools that you would use when you graduate.
Great, thank you so much. Our next question is, what languages does the USC Computer Science Department focus on?
C++ to start with, and then there's Java that comes actually after that.
Yeah, that's fair.
We use Python and AI.
Yeah, that's right. Python. There's a lot of scripting.
Like, I'd say the three big ones are C, C++, Java, and Python, right?
Yeah, that's fair.
And just to that, make sure I've got this right, but sometimes different classes use different languages. It's not like that's the only ones they're going to see. Sometimes people will jump in with different elements at different points, maybe different projects. People come be creative with what languages they want to use on a particular solution to a problem.
Yeah, in data science, for example, I'm teaching a course right now. One of the homeworks is in a language called R. Just like the letter C, there's a language called R. So I teach enough R so that they can get the homework going, but it's a vast language, but it's a nice tiny dip the toe in the water. So we do use little languages like that in other courses as well. So it's not all just C, C++, Java, Python.
Awesome. Is there an ice cream truck next to you, Saty? It sounds like it is.
There's actually music practice going on. Sorry, I'm a little
Music practice. Awesome. Great. I got hungry for an ice cream bar. All right. These questions are jumping around on us, so I apologize. Does the computer science and business administration degree work as a double major? I'll answer that one. No, it is not. It is a hybrid degree program. It's a single degree called computer science business administration. If you go to our website, viterbiadmission.usc.edu/CS, you can see a full degree plan and see all the differences between all the different CS programs and see exactly how it lays out with the 4 years, essentially bringing in undergraduate business courses throughout your 4 years. Compare that to CS and CS games, and also CECS, which is computer engineering, computer science. You can check that out, but it's not a double major. Janice, I'm going to have one of my staff answer you a little more detail on your question related to transferring. Yes, you can transfer. We do specific transfer sessions where we talk about this. We can help prepare you as a competitive applicant, but the answer is yes to that. So yes, we're going to take care of that for you. Bhavesh asked, do you have clubs or groups that are specifically for research, for example, writing papers and publishing them in conferences? I don't know of any specific clubs or groups that are focused on research, because essentially when you do research, you do that.
Yeah, you just go work with a professor on that, and I guess your club is the professor's research group.
Yeah, that's your club.
A club. We eat dinner together, we hang out together, so I guess we're a club. We spend a lot of time together.
And maybe this is for Dr. Nealan. What does a typical day look like for a CS games major? So let's start with, you wake up.
Yeah, a typical day. That's very interesting, because I haven't taken the degree myself, right? So yeah. I can't really say what the typical day is, but here's the thing. So these days, what's been happening is a lot of the people who are in the CS degree, because it's, it is under the USC Games umbrella, which is a joint program between Viterbi and the School of Cinematic Arts. A lot of the classes that are more design focused are happening in the School of Cinematic Arts. And so we've seen a large influx of all the people who are in the CS Games program into our building up there. And it's been amazing, to be quite honest, right? Because what's happening, due to the way we structured the program about a year ago, I think it was exactly 2 years ago, but it came into effect a year ago. Due to the way this was restructured, a lot of the classes that are now taken in the early stages of the design phase, like around the second and third year, happen together with the game design students who are not CS majors, right? They're straight up, they're doing the game design bachelor's degree in the School of Cinematic Arts. So they take a lot more classes on design, while the CS people are taking all the core classes in CS. But then as soon as you start doing design, they all get thrown together in the same classes. And I have to say, comparing this to the way this looked 10, 15 years ago, comparing that to today, all of the students I encounter have turned into what we back then would have called polymaths, right? So at this point, they are so familiar with speaking to each other, both about the engineering side and the design side, that's no longer this two cultures problem where the engineers feel like they're only serving the designers by doing their bidding, right? This is the traditional stigma between the arts and the sciences. That's not really happening. Instead, I'm seeing a lot of collaboration. Sometimes I see engineering students who are less firm with the tools than the design students, and the design students teaching the engineering students how to get better at using Unity or Unreal. But then later on, when they run into a harder engineering problem, the engineering students actually helping the design students better understand the design of the project. That's what's happening when you are in those classes. Beyond that, for that program, we went through great lengths, and GJ can confirm this, to make sure that you can actually take a full minor entirely outside of Viterbi or SCA, right? So you have 21 units, which is a lot. You have 21 units of elective credits. And that's enough to take a minor, say in architecture or business or any other field that you find is somewhat related to the things that you would like to do. Or you can use those credits or those units to just fill out the other spots where you feel that you would like to take classes within one of the two programs, right, that are related. And again, those are the things where the advisors will be a huge help to you to figure that part out. So again, a lot of flexibility, right? There's a lot of flexibility, which again goes back to what I said earlier about you being like really, really interested in wanting to do this and well prepared so that you have a good idea of what it is you want to do. You will not potentially know that in your first semester or the second semester. So don't stress out over that. It's going to take a moment till that all falls into place.
The next question is actually related to something I neglected to ask in the beginning of this, but what's the difference between computer engineering and computer science? And then what's interesting is that the tagged onto this is something I want to focus on, which is job opportunities. Obviously, one of them is better and one of them gets better jobs. It's the assumption built into this. But let's talk about the difference curricularly between computer engineering and computer science. And then let's talk about where job opportunities happen for these different degree programs.
When you say computer engineering, do you mean like the standard ECE degree, or do you mean the joint degree?
I would actually talk about all three. And if you want to, I can give a quick primer on it. It's up to you.
Sure, I can kind of start.
Yeah, go for it.
I think that CCS is a joint degree between the electrical and computer engineering department and the computer science department. And so you're going to take some of the same courses that the computer science majors take and some of the same courses that an ECE major is going to take. So it's a little bit of a merging and a mashup. Essentially what that means in practice is that you have fewer technical electives because you're taking some from ECE and some from CS that are both required and trying to mash these two degrees together. Electrical and computer engineering tends to be much more rooted in the basics of hardware and design, moving from very low-level circuitry up to high-level computer architecture components. On the computer science side, it's a very broad area. You take the core classes in programming and theory, and then you're also focusing on a bunch of what we call technical electives, which can be things like machine learning, artificial intelligence, databases, graphics, and things like that. So curricular-wise, that's how you could separate out these three.
Great, thank you. I always like to think of it like the perspective like hardware. The EC, electrical and computer engineering, is the degree focused on hardware. Computer science on this side is focused on software. CECS is a kind of a 50-50 split between the two, computer science. Now, naturally, a software degree has hardware elements. A hardware degree does have software elements, but it's just a question of where you want to lean. And for our students that are out there, right now, you're not locking yourself in. This whole spectrum of computer science programs, including kind of these hybrid degree programs and specializations of computer science games, computer science business, are kind of coming off of that software degree program. Ask yourself a question: Are you leaning more hardware? Are you leaning more software? Or are you really stuck in the middle? Well, then that's how you know what degree you want to put down in your application. And as you get started, students move across this spectrum throughout their undergraduate coursework. You're never locked in. Don't overthink this. Think about what sounds the coolest to you now, and even if that's something not in engineering, or you want to move from computer science into another engineering degree program, that's fine too. But don't stress about this. It is much more of an evolution. It's a journey. It's an experience. It's something that you go through. And as you take these courses, you'll find yourself gravitating to different courses, as we talked about before, with choosing electives and choosing opportunities of if you want to emphasize more on software, hardware, or specializations in between. So can we talk a little bit about job opportunities, where you see students go? And my joke earlier was that like hardware, software jobs, not necessarily different companies or different opportunities, or one's more successful than the other, but where do we see our undergraduates go after they get their degree program of getting a job?
Well, if you see a full range of where the students are going after they graduate, just because there's a lot of computer science students here, and they're very sought after. I think we're one of the top 4 feeder schools for Silicon Valley. So a lot of those big companies that you hear up in Silicon Valley are coming here to USC to recruit programmers and developers. LA itself has a huge amount, and we call it Silicon Beach. It's not as famous as Silicon Valley yet, but one day. But there's a lot of companies here as well that are hiring, and they range from names you recognize like Snapchat to smaller companies that are doing like startups through the different kinds of incubators, either USC or just, it's a big city with a very thriving startup community as well. So huge range. And then at the same time, we also have the very traditional government contractors like Lockheed Martin and Northrop Grumman that also hire a lot into developing aerospace software.
Yeah, I'll add on a few names. Amazon is one of the companies that hires the most, which is true probably of most universities, most computer science programs. Amazon, Microsoft, Apple, Google. Pick a device that you own. Look at the back. Look at the name on the back. That's who's hiring at USC. Is usually the end of it, which is true of most top engineering programs. But all of them are recruiting regularly at USC. And what I also want to tell students looking at computer science is, it's often the case that as a computer science student with a degree in computer science, you don't necessarily work at a quote computer company. All companies hire computer science students, computer engineers, and so financial companies, consulting companies, different types of opportunities out there. There's a lot that are hiring computer science, and they all need different types of programmers or software solutions. So don't think so limited on like, I have a computer science games degree, I'm just going to work at a gaming company. Google hires computer science games degrees students all the time. For a lot of their solutions, and you never know what might be out there. Educational companies, there's a lot that's out there. So to think as broad as you possibly can. Don't just think about what you specifically are thinking about right now. I think we have time for 2 more questions, and so I want to get to this one. I'm going to come back, Melissa. I'm going to come back to your question. We're going to end on that one, but Giuliana, this is the one we're going to do first. What's the culture like among CS students at USC? For example, another university has startup fever, they hear, and that's all they're ever talking about. But what's the culture of USC students, if there is one, if you can actually put your finger on it? That's always my problem. I don't think there is a specific one.
Right. No, because we're not in Silicon Valley, we definitely are not infected by that fever. So yeah, what Stanford does in the USC definitely does not do. But that said, we definitely have people that are pretty, like business minded. So they're always thinking about, how to, for example, form a startup, compete in hackathons and meet people and, networking. All of that culture is definitely there. But I would say there's more focus on the academic background as opposed to how quickly can I exit what I'm doing and go start a company, become a millionaire. I don't think we do that much, of that kind of thinking, where the whole goal is to come into CS, form a company, leave, sell it in an exit strategy. I don't think we do that. It's more definitely culture of educating, learning the basics, I think.
So yeah, I just want to second what Saty is saying. And on top, there's just so many clubs here that are affiliated with computer science. There are some clubs that the students are focused on startups and learning about how that process works and trying to participate. Then there's other ones that are organizing hackathons and other ones that are trying to figure out how to apply computer science and programming skills to different kinds of problems that exist out there. And so it's just, there's so many different activities, but I think that's really, like I mentioned this earlier, just one of the really cool things about the undergraduates here in CS is how involved they are in things that are not just class. It seems like everybody's got something fun that they're up to the moment they get done in the evening with their classes.
Yeah, it's the question that we get around a lot of engineering degree programs is, what's the culture like? And the struggle of anyone you ask that question to at USC is to come up with one answer, because a lot of students choose USC for very different reasons. And it's one of my favorite things about USC is that they got turned off by the everyone looks like this or does this at XYZ university, or that's a place to go if you want to do blank. USC has students doing all of those different elements. We do have a startup culture. There definitely is one if you want to be involved in it, but it doesn't take over the school. We have this gaming culture of creating games and being involved in that games degree program and the interactions across academic environments with the School of Cinema and the School of Fine Arts. That exists. We also have students that are athletes. We have students that are musicians. We have students that aren't any of these things. They're kind of in between all that. We have students that have never programmed before being very successful in computer science, and we have students that have been programming since they've been 3. All of these people are coming together in an incredibly diverse mix of students where honestly, it's really hard to describe other than they love what they're doing, they love who they're doing it with, and they really enjoy their time. And that's something that is, I think, interesting to talk about with a rigorous computer science and engineering degree program, that they enjoy it. And there's often a correlation of the class that they think is the hardest is typically the one that they enjoyed the most when they get done it. Never when they're in it, but when they're done with it, they always look back on it and say like, no, that was actually cool. Now I know how to do this. It's a real fun survey I have for my students. What was your hardest class? What was your most fun class? Like, oh, it's the same one. That's so weird. That ends up happening a lot. My last question for you all, and I'd love to hear all of your input. I'd like to start with Dr. Nealan, then we'll go to Dr. Raghavachary, and then Dr. Halfond in this order. What makes the computer science department stand out at USC compared to other computer science programs at other universities?
You kind of already took that away just now.
Sorry, did I take the wind out of your sails? I'm
I'll
sorry.
reiterate it. So I've been, I don't know about the rest here. Like I started my career at Rutgers, New Jersey, and then I went to NYU, and then I came to USC. So I've been in 3 different
Good
computer
mix.
science departments. And this one by far is the most collaborative across the school, right? So one of the main reasons I came here in the first place was because I heard of this amazing collaboration between the engineering school and the arts department. A very rare thing, I might add, right? It is not common at all. These departments are very often at each other's throats. And so I can say this is for me the main feature, right? The fact that all the different departments that I've been part of in the different schools, right? They all talk to each other. Yes, their core interests are sometimes fundamentally different, but they try to see past that to understand that at the end of the day, the mission here is to make the environment a more productive one for the students, right? So I do know that the schools that I'm part of commit to that mantra very, very intently. And most of the other schools I've been to before, even the ones I've collaborated with and the ones I've visited in Tokyo, Zurich, and Tel Aviv, and all over the globe, right? Very rarely have I seen a willingness to reach out to other departments, to understand that at the end of the day, we're all humans and we're social, and that does trump to some extent the fundamental differences in the way we think about the different problems that we're trying to solve in the world, right? So that would be for me the biggest feature of USC that I have not seen in that way anywhere else I've been in the world.
Great. Thank you. Dr. Raghavachary.
I'm going to say something very similar. CS departments can be pretty elitist. They can be ivory towers, and that's usually how it is in most places in the world. But USC has connections with practically every other department. It can be arts, it can be a school of communication. I'm actually sitting outside the journalism department, neuroimaging, biomedical engineering, just basically about everything at all. In fact, our dean, Yanis Yordas, he likes to say CS plus X, where X can be anything. So CS is one of those pluggable, fields that we usually love to apply to practical problems in the world. So that is how the department sees itself, not just isolation, just teach computer science theory and just go away, but more like what can you do with it? So it is all these connections that actually make our department pretty special.
You get the final note, Dr. Halfond.
Okay, I have kind of a nuanced answer. I hope this works. I can communicate clearly, but a lot of times when you look at different departments and universities, you say, oh, this department has the best in X, or this has the best department at Y, or the school is, ranked number 1 in this or that. And one of the things that I've noticed here at USC is that not that, please don't take this wrong, but it's not that normally we'd say, oh, we're number 1 in this category, number 1 in that core category, but we're right there across all of the categories. We're right there near the top of almost all the things that matter, whether it's like student engagement or student clubs, quality of research, the amount of classes that's available. So we're just very broadly doing well in a whole bunch of things, which I think really makes for a wonderful environment for students, because you don't feel like you're giving up something. You get really good at almost everything, which is, I think, how I'd characterize USC.
Thank you for that. I couldn't have said it better myself. Thank you to all 3 of you. I want to be respectful of your time. We've gone for the full hour. Dr. Halfond, Dr. Raghavachary, and Dr. Nealan, it was a pleasure having you here. I am super thankful for you spending some time talking to our prospective students that are out there. For all of you that are here, thank you for joining us. I want to leave you with one other final note. There's a lot of questions that are gone unanswered, but we have these sessions specifically on admission information, specifically about the application process, where we can dive a little bit more into the curriculum. They're smaller sessions, they're personal in nature, where we can answer your questions. Make sure you join us on one of those. Spaces are limited because we keep them small, so we can make sure we answer all of your questions. We run them every Tuesday and Thursday for first-year students and every other Friday for transfer students. Thank you again. I appreciate all of your times. We look forward to seeing you. If you missed any part of this, we'll have a recording up at the same website that you got the registration for this, and you can watch that anytime over and over again. We love the YouTube clips. Any questions for us, reach out to us. Always feel free to reach out to us via admit@usc.edu, or our phone number is 213-600-9919. Thank you, everybody. Have a great night, faculty. I appreciate it. Fight on, everybody.
Thank you.
Goodbye. Good luck, everybody.
Bye. Good